Let's look at GDL in the context of a specific game, namely Tic-Tac-Toe. As fundamental entities, we include white and black, the roles of the game. We also include 1, 2, and 3, which are we will use as indices for rows and columns of the tic-tac-toe board. And we'll use X, O, and B, meaning blank, as marks that go in the cells of the tic-tac-toe board. We'll use the ternary function constant cell together with a row index and a column index and a mark to designate the proposition that the cell in the specified row and column contains the specified mark or blank. For example, the datum cell 230 says that there's an O in the cell in row 2 and column 3. We use the unary function constant control to say whose turn it is to mark a cell. For example, the proposition control of white denotes the proposition that it's white's turn to play. In tic-tac-toe, there are only two types of actions a player can perform. It can either mark a cell or it can do nothing, which is what a player does when it's not his turn to play. The binary relation, binary function constant mark, together with a row M and a column N, designates the action of placing a mark in row M and column N. The mark placed there depends on who does the action. And going back to the object constants, we have no-op, which refers to the act of doing nothing at all. Finally, we have some helper vocabulary, row, column, diagonal, line, open, whose purpose will become clear soon. The state of the game of tic-tac-toe is an arbitrary subset of the propositions. Propositions in a state are assumed to be true whenever the game is in that state, and all others are assumed to be false. For example, we can describe the tic-tac-toe state shown here on the left with a set of propositions shown on the right. Cell 1, contains an X, cell 2, contains an O, cell 3, contains an X, the other cells are all blank, and it's black's turn to play. Using this conceptualization of states, we can define the game of tic-tac-toe with a small set of logical sentences, as shown here. The game has thousands of states, yet it can be described with just one page of rules. A similar parsimony is possible for other games. For example, chess has more than 10 to the 30th states, and yet it can be described in about 4 pages of rules of the sort shown here. Let's look at each of these groups of rules in more detail. We first identify the two roles in the game, namely white and black, using the role relation. Next, we define the propositions in the game. Since there are only 29 propositions, we could do this by writing out 29 ground atoms. However, we can do this more economically by writing just 2 rules, as shown here, together with some ground atoms. The first rule says that an expression of the form cell of x, y, w is true if x is an index and y is an index and w is a filler, that is, we'll see x, o, or b, and an index is 1, 2, or 3. The second rule says that every player, that there is a proposition of the form control of w for each of the 2 roles in the game. Now, we can do the same for actions. An expression mark of x, y is an action for w if w is a role and x is an index and y is an index. And no-op is a possible action for either of the 2 players. Okay, here we characterize the initial state by writing all relevant propositions that are true in the initial state. In this case, all cells are blank and the x player has control. Next, we define legality. A player may mark a cell if that cell is blank and it has control. Otherwise, the only legal action is no-op. Next, we look at the update rules for the game. In other words, its physics, its dynamics. First rule here says that a cell is marked with an X or an O if the appropriate player marks that cell. And the second rule handles the other player. If a cell is blank and is not marked on that step, then it remains blank. If a cell contains a mark, it retains that mark on the subsequent state. Finally, control alternates on each play. Before we get to rewards and termination, here are some supporting concepts. A row of marks means that there are 3 marks all with the same first coordinate. The column and diagonal relations are defined analogously. A line is a row of marks of the same type, or a column or a diagonal. Finally, a game is open provided there is some cell containing a blank. All right, here we have the definition of goals. A white player gets 100 points if there's a line of X marks and no line of O marks. If there are no lines of either sort, white gets 50 points. If there's a line of O marks and no line of X marks, then white gets 0 points. The rewards for black are analogous. And finally, there's termination. A game terminates whenever either player has a line of marks of the appropriate type, or if the board is not open, that is, there are no cells containing blanks.